Claude Fable 5, MiniMax M3, and Kimi Code all claim they'll write your next feature without breaking your budget, so I pulled every number. Both companies will actually stand behind official pricing pages, model cards, third-party benchmark aggregators, and community reports, and ran them against each other across 5 dimensions. The biggest surprise wasn't who scored highest on coding benchmarks. It's that the model with the best raw coding score is quietly the most expensive model to actually run, once you account for how many tokens it burns just to read your code. Let's start with the number everyone actually cares about first. Can the thing write working code? On SWE Bench Verified, Claude Fable 5 scores 95.0%, according to official docs. MiniMax M3 comes in around 80.5%. Community reported. Kimi Code doesn't have a published figure on this specific benchmark, so I can't put it on this chart directly. That 95% is the highest publicly available score of any model at launch, and it's not a narrow win. Fable 5 also leads SWE Bench Pro at 80.3% against MiniMax M3's 59.0%, a gap of over 20 points, on Terminal Bench 2.1, which tests real agentic coding tasks instead of isolated problems. Fable 5 scores 84.3% to MiniMax M3's 66.0%. Kimi Code does have its own number, 62.0 on Kimi Code Bench V2, but that's measured on its own scale, so it's not directly comparable to the SWE Bench numbers the other two are posting. What we do know is that in direct head-to-head shared tasks on Goldie Bench, Fable 5 beat MiniMax M3 off 26 wins to 18. That's not a coin flip, so if the only question you're asking is, which model writes the most correct code on the first try, Claude Fable 5 wins this test clean, and it's not close. MiniMax M3 is still solid for the price, sitting about 15 points behind on the headline benchmark, which is a real gap but not a disqualifying one. The problem is that raw coding ability and cost per task are two completely different questions, and the next test is where this comparison gets a lot more interesting. That's a model that's meaningfully better at resolving real GitHub issues, real pull requests, real production bugs. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. I went through the official docs, the benchmark aggregators, and the community threads on all 3 of these so you don't have to dig through 12 different sources yourself. Here's where the story flips hard. Claude Fable 5 charges $10 per $1 million input tokens and $50 per million output tokens, according to official docs. MiniMax M3 charges 0.30 per million input and 1.20 per million output. Kimi Code sits in between at 0.95 per million input and 4.40 per million output. Do the math on that output price, and MiniMax M3 is running at roughly 1/40th the cost of Fable 5 for the exact same volume of generated code. Not 40% cheaper, 40 times cheaper. If you're generating 1 million output tokens in a month, that's $50 on Fable 5 versus $1.20 on MiniMax M3. Cached input pricing tells the same story. Fable 5 charges 1.00 per million cached tokens. MiniMax M3 charges 6 cents. Kimi Code doesn't publish a cached rate, so I can't compare that one directly. But on the numbers we do have, MiniMax M3 wins every single line item in this test. For context, Fable 5 is roughly 3 times the price of Anthropic's own Sonnet 4.6 tier, according to community pricing comparisons. Kimi Code undercuts Fable 5 by about 12 times on output pricing, but it's still 3 to 4 times more expensive than MiniMax M3 across the board. So on pure sticker price, MiniMax M3 wins this test outright, and it's the widest margin of any dimension in this entire comparison. That's not a budget model pretending to be premium. That's a premium model priced like one. Sticker price only tells you half the story because two models charging the same rate per token can cost wildly different amounts if one of them needs more tokens to do the same job. This is where Fable 5's premium coding score gets a lot more expensive in practice. Community reported data shows Claude Fable 5 needs 69% more tokens than MiniMax M3 to encode the exact same piece of text. It gets worse on the output side. Fable 5 is designed to think longer before answering, which according to vendor claims means it consumes roughly twice as many reasoning tokens as a typical response. Kimi Code, meanwhile, cut its own reasoning token usage by 30% compared to its prior version, K2.6, according to the vendor. Stack those two numbers together and you get the real headline of this whole video. Fable 5's $50 per $1 million output price tag isn't actually what you pay per task, because it needs 69% more tokens to read your code in the first place, and roughly double the reasoning tokens to answer. Its real per task cost is meaningfully higher than the list price suggests. This is the gotcha nobody puts on the pricing page. MiniMax M3 wins this test, and it's arguably the most important one in this whole comparison, because it's the one that turns a benchmark leader into an expensive habit. That's not a rounding error, that's Fable 5 needing to process almost 70% more raw material just to read the same input. MiniMax M3 reads more efficiently. Stick with me because the last 4 tests are where this decision actually flips. Speed matters if you're running an agent loop all day and waiting on responses between every call. MiniMax M3 posts 82.8 tokens per second throughput, community reported, with a time to first token of 1.57 seconds. Kimi Code runs around 41 tokens per second on standard requests, though its high-speed tier claims it can push up to 100 tokens per second. Kimi Code's time to first token sits around 2.81 to 2.97 seconds. Claude Fable 5 doesn't have a published throughput or time to first token figure I could find, but we do have one comparable number. At max reasoning effort, Fable 5 takes a median of 60.8 seconds per task, according to community benchmarking. That's not a knock on the model, it's thinking longer and deeper, which lines up with everything we saw in the token efficiency test. It's slow because it's thorough, not because it's inefficient at the API level. MiniMax M3 takes this test on raw throughput, nearly double Kimi Code's standard tier and the clear leader on time to first token. If Kimi Code's high-speed claim of 100 tokens per second holds up under real load, that's worth watching. But as of now, it's the vendor's number, not an independently measured one. Last test, how much can each model actually hold in its head, and how much can it hand back to you in one shot? Claude Fable 5 and MiniMax M3 both support a 1 million token context window, according to vendor docs, so there's no separation there. Kimi Code trails both at 256,000 tokens, a real limitation if you're working across a large repository. The bigger gap is on output. MiniMax M3 supports up to 512,000 tokens in a single response, community reported. Fable 5 caps out at 128,000 tokens. Kimi Code's default output sits at 131,000 tokens. On modality, all three accept text and image input. MiniMax M3 and Kimi Code both add video input, while Fable 5 supports text, image, and file input, but stops at text output. MiniMax M3 wins this test too, on the strength of that output ceiling alone. That means MiniMax M3 can generate 4 times what Fable 5 can in one response, which matters a lot if you're asking for a large file rewrite or a big batch of generated code in a single call. Claude Fable 5 wins on raw coding ability, period. Its 95% SWE bench verified score beats MiniMax M3's 80.5%. Its 80.3% on SWE bench ProTop's Opus 4.8's 69.2%, and it went 26 and 18 against MiniMax M3 in direct shared tasks. Now, Claude Fable 5 wins on raw coding ability, period. Its 95% SWE bench verified score beats MiniMax M3's 80.5%. Its 80.3% on SWE bench ProTop's Opus 4.8's 69.2%, and it went 26 and 18 against MiniMax M3 in direct shared tasks. Kimi Code is the wildcard. Its high-speed tier claims up to 100 tokens per second. It cut reasoning tokens 30% versus its predecessor, and it's open source under a modified MIT license, but its 256K context and lack of a directly comparable benchmark score keep it out of the default pick. MiniMax M3 is the winner here, 4 dimensions to 1. It delivers around 80.5% of Fable 5's coding ability at roughly 1/40th the price, with 4 times the output limit and meaningfully better token efficiency. If you're running high-volume, everyday coding work, that's not a close call. Claude Fable 5 still earns its premium if quality is genuinely non-negotiable and budget isn't the constraint. Its 95% SWE bench verified score is unmatched. But that premium is bigger than the sticker price shows. Fable 5's $50 per million output price tag is the headline, but it's not what you actually pay. Because it needs 69% more tokens to encode the same text as MiniMax M3, and roughly double the reasoning tokens per response. The real per-task cost runs well past what the pricing page implies. That's the number marketing never puts on the slide. If you want to see how these three actually behave in a real multi-file coding session, instead of a benchmark chart, that comparison is coming next, and it's the one that decides whether Fable 5's quality edge survives contact with a real project.